Alrighty, so now we are actually live for real. Before we were just streaming our beautiful start screen. And I remember to mute myself so I don't hear myself at the same time. So we want to look at the intrinsic stuff that Tanner, I think, reviewed with us like a long time ago. And so this time we want to go over the specifics that are relevant for the the ARM design, I guess. But so how do you want to do this? Do you want to go over the meta issue first? Do you want to discuss the individual items then, or how do you want to drive this?
I think it'd be better to go over the meta proposal. I think for the most part, the sub-issues we're going to end up blanket approving, provided that the overall shape of the APIs looks correct, which I think is the important bit.
Sounds good. So I think Steve filed this probably, right?
Yeah, Steve filed the majority of the ARM issues.
Steve, do you want to walk us through them then?
Sorry, I haven't really thought about walking you through them. We can talk through them. I wrote these very quickly when I wasn't a Microsoft employee. I quickly was this one you got on the screen right now was drafted to cover the SIMD issues, so the SIMD subset of the Intrinsics, which is what I thought I was going to be working on heavily at the time, and I did work on them somewhat. And so, because I started filing a whole bunch of API proposals, I started thinking maybe I should draft some naming conventions and argument conventions,
right,
rather than sort of minutely reviewing every one. And so this document really came from a review of the ARM v8 ARM reference manual, and specifically the SIMD subset of the AR64 instruction set.
Right.
And so the naming convention here was sort of my proposal to try to convert the squirrely assembly into human readable .NET style naming conventions.
Makes sense. Yeah, I think we talked about this before. That we basically only said, like, if you look at the instruction set, there's very often just abbreviations, and if you just spell them out, we basically get a name that is probably good enough for the most cases, unless it's something that is really weirdly butchered or something. But I also don't think we need to innovate too much here, because I think some of them will probably be, very domain specific, where it's just you have to know what those terms mean in order to make sense of it. But I think that's generally acceptable, right? I mean, I think last example that Tanner brought up was, fused, multiply, add. I mean, like, it says, yep, you have to know what this thing does, but it gives you enough keywords to Google as well. So I think it's better than some weird abbreviation that is very common, but not specific enough. So then, excuse me. So you said you want to drop the adjectives because you think they're handled by the type system. Do we need new types for that, or is it largely all the existing types they already have?
I think the unsigned long, signed long, and floating or double is sufficient.
Right.
Yeah, for the most part, these were envisioned to reuse the vector 64, vector 128, and if we ever support the SV extensions in the future, 256, 512, and upper types, and then the 10 primitive integer or the 8 primitive integer and 2 floating point types we have.
Right. I just quickly see one thing. I think there's a type called SSE, right? Probably the easiest one for me to find right now.
SSE is the...
yeah, I'm just looking for one to find at least the namespace where they're in.
So Intrinsics. I think right now these are put under System Runtime Intrinsics ARM for ARM32 and ARM64 for 64. And then most of the SIMD ones were put under a SIMD class name.
We also have directly in Intrinsics, we have the vector 64, 256, and 128. So then
those are the base shared types between both x86 and ARM.
Yeah, if only I could navigate down, this would be super helpful here.
And then I put a link in the Skype chat which is to the official ARM page for their SIMD intrinsics. It's listed under their Neon page, but it covers A32 and A64.
I see.
And the big difference between the ARM32 Neon and the ARM64 SIMD is the additional support for double precision and a few other new APIs.
So one of the things that sort of drove the decision to put this in a separate ARM64 namespace was ARM32 was the discrepancy in the support of types. And so in order to make it clear which types were supported, the ARM64 hardware intrinsics were kept in a separate namespace from ARM32 or ARMv7.
And MSVC, GCC, and Clang for their ARM intrinsics, they also keep them completely separate for 32 versus 64. So there is prior art for that.
So I remember a long time ago when we talked about the intrinsics, we said there are versions of specs, and we're gonna have separate classes for different versions.
Yeah, for each.
And that to me totally makes sense because, well, spec is at some point ratified and it's closed, correct? So version 2.1 will always have these instructions. When we separate APIs into different classes based on like manufacturer of the chip and some other things, do we expect it to change over time? Like, for example, today we say, hey, this instruction is specific to ARM, and then 2 years later, x86 chips have, add the same instruction. What are we gonna do?
They could be the same instruction functionally, but they would be different instructions. So, and different architectures and different ISA check bits. So they'd be different classes.
We had talked about, I believe to your point, we had talked about taking functionality that was common to multiple different chipsets and also exposing those as more generic APIs, like
Right.
more typical .NET
Yeah.
APIs, in addition to what's being displayed here.
But that's
right?
exactly the issue, that the common subset can grow over time.
Mhm.
And then, then there will be some confusion, like, where do I look for this, not API, for this instruction? Is it in, chip-specific type or in the common type?
I believe the idea of these types is that they are always chip specific, right? So the idea is that they're all supported by the codegen in the sense that they will, if you call them, they will just emit the exact opcode that the architecture supports. And if you want to emit different code between, ARM and let's say x86, you are supposed to write that
But
code
as
yourself.
Levi said, there are some that we already put in common type.
No, because they would be in a different namespace. They would be not in.
They wouldn't be intrinsics in the same way.
Yeah,
They'd
they-
just be a .NET API that we call
Yes.
behind the scenes.
There would be-
That's what you.
Yeah.
Oh,
Yes,
okay,
yes.
okay.
Yeah, so
Yeah.
you might have something like system.bitmanipulation.popCount, and then
Okay.
that under the hood could call x86 popcount or
Right.
ARM popcount,
Yes.
and then
And-
have a software fallback as
Yes.
well, which these do not have.
And that's the important part too, what Tanner just said. But the ones that we've considered moving into a common namespace would presumably have a software.
I see. So basically, if something is common, we don't even consider it intrinsic.
Right.
We consider it .NET API.
Yes.
And I understand.
So I think the other thing is, like, we learned this from our other generic SIMD work that we did earlier, that you need to have the right granularity as well in order to make software fallbacks not insane. I mean, the vector ones that we have are, I forgot what the perf measurement was, but it was like 3x lower than the naive implementation, which basically takes away all the value, right? And so you would expect like something like CRC32 or whatever, like when you have an intrinsic, right, it's a one-line instruction. Otherwise you have the, I don't know, 4 or 5 lines of code that you have to write in C#, whatever, unsafe code in order to do the same thing, and then you have, a sensible API, I guess. But I think for some of these things, it's like I don't even know what the common API would look like, right? Unless you literally have the exact same instruction, which I don't think is super common.
Things like pop count are easy for it.
Yeah.
This is a well-defined unary operation, and we make a function that is the well-defined unary operation.
So then, I think argument conventions, I think we talked about this as well. We generally refer to them as left and right. I believe that's somewhat consistent with what we've done in other places.
For the x86 ones, we haven't necessarily called them left and right, unless they explicitly make sense as left and right. There's a number of them where we've had to call them like source versus upper instead, because they may have different semantics than just left and right.
Yeah, I think left and right makes sense if it's a normal binary operator, right? Where you can usually swap them, right? Or it makes sense.
And then one of the other things that needs to be discussed is for the between x86 and ARM, the instructions, some of the instructions may do basically the same thing, but they may have different conventions. Like on x86, you've got and not, which actually functionally does a not and. And you've got the same instruction on ARM that does the and then the not instead. But if we call them both and not, it may be confusing to some. And
yeah, so to me, honestly, for the intrinsics, I don't think alignment between them is super important. I think the design, like how do we expose intrinsics, should follow a set of patterns that are the same. But if one instruction set does operation A followed by operation B, the other way does it the other way around, I would say I wouldn't try to abstract this, because the whole point of these things is that they're so close to the metal that if you know what you're doing, you can do what you want to do. And then there is completely separated from the intrinsics as higher level APIs that we try to say, how will we expose a higher level operation to the net developers, and that's the place where I would try to align them.
I mean, another argument for making these low level is presumably sometimes you'll be transliterating them from a sample or something that's written in actual assembler, and so you're looking for and not.
Well, yeah, I would be just careful how far you drive this, because if you look at the C++ intrinsic names, for example, like they are so ugly and undiscoverable that it's like, well, if you make this a goal that you can just copy and paste them right in C++ code, then these APIs will not work very well as they currently are designed. But I also think that honestly, those are somewhat better than what C++ have done.
But to be honest, like if you're taking one of the C-style intrinsic APIs and just like copy and paste it into a search box, presumably the correct thing will come up.
Yeah, I would hope so. I mean, that's the other thing I think.
Right now, all the doc comments have the C++ equivalent documented there.
So for the binary operators, would we say always left and right on a binary operator, or only on an associative operator? Because like for division, I think that we normally name them dividend and divisor, so that we're telling you which one is which. Especially for things like, I guess div rem is a binary, or a tuple to tuple. So we need to name the out positions on that one.
Yeah, we can name them A, B, and result. So
yes,
awesome.
We completely screwed up our div rem, because every time I need to use it, I need to go. I test it to remember which thing it does.
If you use paper and pencil and they are on left and right, you can use left and right. But for division, you usually don't.
Top and bottom.
Yeah. So I'm just asking.
How you do your division.
Do we want to just say if it takes two arguments, they're left and right, or do we want to?
I think your comment of only if they're transitive makes sense.
Yeah. I mean,
if you need to care which one's which, we should tell you which one's which.
Well, so subtraction is not transitive,
right?
Yet left and right makes sense. I think it's more about paper and pencil, like how you write it.
Yeah, and in the x86, and I think in the other places where I normally see divide, we also use left and right, just because you've got, when you write in C# code, you do left, operator, right.
Okay.
And you're expected to know the semantics of what the left versus the right is.
Did we expose an intrinsic for div rem?
No, there's a proposal for that.
Okay.
It falls under that general category of this is part of the base CPU. It's on every CPU ever, but it may have platform or architecture specific behavior that is not easily representable in C# code.
We have already
Sorry, I missed what you were just referring to there. What instruction was that?
Div rem. So just div and
div
idiv.
Right.
By the way, we have map.divrem, which doesn't use the divrem instruction. It just actually does division twice,
They
which is very annoying if you try to print numbers.
actually it doesn't and in a I think a left shift right now instead because it's faster than doing the
Oh,
two
yeah, maybe.
divisions.
Yeah, but to your point, I think your question is like, would we fix them to actually use the intrinsics once we have them?
Yeah, I
think
would
the
just
answer
use
is
the
yeah.
API instead
Yeah.
of
The
the implementation of
But it
this.
has behavioral differences, though. That's the
Really?
issue, right? Isn't that what you just said?
No, so the reason it's doing something that's functionally equivalent but is faster to do than two division operations because the JIT today does not know how to do
Got it.
a single divide and also give you out the remainder.
Yeah,
Well,
by
your
the
point,
way,
I think your point earlier was that you cannot easily represent the behavior specific of different in the C#.
Well, like you can't express it at the language level, but you can express it in an API with an out parameter, for example.
Oh, I see what you're saying. Okay, that makes more
But
sense.
with our existing div-rim, we named the parameters like A, B, and out C, and it's like, well, did we out the result of the division or did we out the remainder?
so going back to the
Good job,
plans
FXDC 20 years ago.
fixing it, do we have actually serious plans to fix it? Because we would use it in our formatters. You know, we
You
actually
mean
added
fix the name?
no, the implementation of map.different.
Basically,
Well-
if we're adding all these APIs, would we go back through the framework and start using them internally?
I would hope so because it would be faster.
Yeah, we would want it to happen because we have UTF-8 formatter that actually does it inefficiently because of this issue.
Like for divrem today, there's a to-do issue 3439 restore to using mod and div when the JIT's able to eliminate them to one idiv.
So, by the way, is there any intrinsics right now in math? Or they're all software?
There's no intrinsics. They all have software fallback, but there are some that will, when the underlying CPU supports it, emit the direct instruction. Like math.round, when you have a CPU with SSE41 support, will emit round PS instead.
I see.
And square root, since like the dawn of time, will emit square root SS.
Okay. So it's not quite as bad that everything's super slow, but like there's probably some low-hanging fruit there once we have the intrinsics.
I know our native compiler also treats more of the math stuff as intrinsics as well.
Yeah.
All right. So then I think we talked about most of these. Yeah, so one question that I had is like, do we have any cases where instructions would fail?
At least on x86 today, there are a few functions which are x64 specific. They're generally the long overloads, which will report as is supported because they're in the general ISA. But if you try and execute them on a 32-bit machine, they'll fail. And that's something that we're supposed to discuss next week with the x86 design review.
I was more thinking, like, do we have any cases where, like, how would we raise exceptions from the intrinsics, right? Is this something we can generally do, or is it something we can't do? Do we ever have to do that?
Right now, the ones that will throw exceptions are, like, if, for example, if you've got something that requires a constant parameter,
Right.
and that parameter only accepts a 0 through 128 and doesn't support 129 through 255, it
Right.
will throw an argument out of range exception.
Right.
And that's done by the J.
Okay.
There's also the not supported exception when the hardware that's running doesn't support the intrinsic.
Right.
The stuff like divide by zero just returns some kind of infinity.
Yeah, for any instructions that throw an exception, like for example, if it requires an aligned parameter, then the instruction will just raise the access violation exception because the JIT already handles all of that behavior from the instructions. But otherwise, they just return whatever result the instruction returns with no fiddling around with the bits or anything.
But it uses the flags register to determine what to throw. On instructions that we tell it to care.
Well, it's just the general, like, maybe Carol can explain it better, but the JIT has all the functionality, say, like, if an instruction tries to access memory, then the CPU itself raises some exception internally, and then the OS catches that and raises it back up to us, and then we convert it to, like, an access violation exception.
Because that's how null ref
Right.
some of the powers.
That's my understanding as well.
So there's like no, we're opting this instruction into this. It's the instruction will just do this, and then the JIT has to handle it.
No, so the argument exception, or the
Oh, yeah.
like argument null, that's a check on the way in, not checking an error flag on the way out.
Right.
Makes sense. So this is just basically a summary of where we are, right? Is that right, Steve?
Yeah, this is if you looked at that table of SIMD instructions, this is sort of the outline of the classes of instructions. I was sort of keeping track of which ones I had created an API proposal for and which ones I hadn't. I think this is a little out of date. I think there's proposals for a few that have been implemented that aren't in here yet, as the associated API proposal numbers isn't here.
Okay. Yeah, I think there's a long list of issues that are already just open that kind of attached to the original invite. All right. So, is there any more questions on this one? Otherwise, I would just jump into the actual API shape.
The other thing that kind of crosses between both x86 and ARM is so the majority of intrinsics are a one-to-one mapping with an underlying instruction, and they're basically contracted to emit that instruction. You just don't get to choose the register or the memory operands. The JIT decides that for you. There are a number of functions, though, which are basically helper functions that represent core functionality, like reinterpret cast or create a vector 64 and set each element or set all elements to one value. That are they basically have a software implementation that we build up using the other instructions. They're not contracted to do a particular instruction. For those, there's been discussion and requests on, do we keep these separate between the two, or do we expose these operations on the vector 64 base types or in a general shared class?
So my gut feeling would be I would try to centralize that, because that seems like very unfortunate if we have different behavior for things that are completely hardware independent, like setting all values to one. All slots in the vector to one value seems like a thing that should just work the same.
So one of the issues is that like ARM64 supports vector 64 and vector 128 here, I think, if that's the right naming convention. And the x86 supported 128 and 256. So if you start trying to figure out what's supported, keeping it with the intrinsics, we've had this sort of idea of there's an is supported property in every one of these classes,
right,
so that the programmer can figure it out. If you start moving it outside of the intrinsics, it's maybe a little harder.
Well, I would then say, like, setting all, elements in a vector to a specific value, I would hope this would be a BCL-ified API that happens to use intrinsic, but I don't have to write it myself. Like, I can just call vector to 128, set all to 0, and then, on ARM it does this, on x86 it does this other thing to be as efficient as possible, but I don't have to write that code.
But I think Steve's point is, for something like ARM, which doesn't support vector 256, would we also have a vector 256 is supported to say, like, this, if you called one of the functions, like set 0, would that just work at the JIT level, and the JIT would have to do the software implementation for those specific general, or would we just say it throws on ARM because ARM doesn't have the hardware support for this?
Well, I would say if it's not in an intrinsic namespace, it should not fail, because that would be generally the expectation of these APIs. Now, I think for the vector types, my understanding was that they will always be supported because we can always have a value on the stack of that size. I would say in those cases, you should probably have an else at the very bottom that says if nothing is supported, just fill it with a for loop, and then it might be slow as hell.
But then all operations on vector 256 would work.
Or
just this one.
Just creating and initializing.
Well, I think there's none
so
of. I don't think there are any operations on vector.
Yeah, there's no operations on it today. It's
just a data holder for these intrinsic APIs for the most part.
Okay, let me restate. Like, not methods directly on the vector 256, but if I'm on ARM,
yes,
can I use vector 256?
Well, I would say that you will have a bunch of types,
yes,
that are in the ARM specific namespace. Those have an is supported property because they represent instruction sets, and those that take a vector 128, yes, you will operate on them, right? But then the vector 128 by itself is useless. It just holds the data. So you can use all the instructions that are supported, and the ones that aren't.
There's currently no ARM instructions that use a vector 256 proposed.
Yeah, so why would you make one, I guess?
Yeah, so this is what I was kind of trying to get at. I think we should either make like one size vector, it either works or it doesn't work. We shouldn't be like, oh, well, setting values to zeros and ones, that will work, but anything else will not. That's kind of strange.
No, but what I'm saying is that it depends on where the API is. Right? If the API is on vector, it should work everywhere. If the API is on an instruction set specific type, well, then it would work if that instruction set is supported. So it's a pretty straightforward mapping from developers.
And we already made vector 256 work on ARM. It just doesn't do anything.
It's a type, and if there's no hardware support, then it works like a regular C# type. So if you said vector 256 x equals default, it will at the C# level just call the default constructor, and you just can't pass it to any APIs that would do anything useful with it.
Which is why I said, I don't think the vector itself should have any operations. It should all be somewhere else, except for the initializers.
Yeah. So reinterpret, cast, initialize.
Right. You can pass it, and you can read from it. Just no operation will ever act on it unless you wrote it yourself.
That makes sense.
And I mean, the other option that we have is we don't have vector 128. 256 in an intrinsic namespace, we actually move them into the architecture-specific subnamespace. But then you have Intel now has one, ARM has one, and they're all effectively the same. They're just 128 bits, right?
And when the SVE extensions for ARM come out and 256 through 2048-bit support comes in, if we presumably add that, then we'll have duplicated types between the two that are identical. And
SVE will require discussion.
Yeah, and x86 technically supports vector 64 via the MMX extensions. Those are just outdated, not recommended for use, and we didn't expose them.
So we cheated.
Well, no one should be using them anyways.
Right. All right, so this is a specific API now. So do we have any generics, or do we always expand them into the specific instantiations that we support?
So for ARM64, as far as I've been able to see, the majority of instructions support all 10 types. ARM32, that's not the case. They generally support 9 out of the 10 types, where they don't support double. But this is a similar question that we've had. With ARM, they kind of exposed everything all at once rather than in multiple versions of the ISA. Whereas with Intel, they exposed only float on SSE, and then they added double in the other 9 types in SSE2, etc.
So what can I instantiate a vector 64 with today? Do we support literally anything, like my own struct as well, or do we always blow up and say it has to be one of the 10 primitive types we have, something like that?
You can use anything, but it won't. You won't get the JIT recognition for anything that's not the 10 primitive types.
So what happens if I call add on my fancy struct?
That would fail at the JIT level with a PNSC.
But it will compile just fine, right? It will.
Right.
Yeah.
Yeah, because that's one of the things where part of the analyzer that I want to get written and that I've started working on in my spare time is if you're using an illegal type for that's not one of the 10 primitives, then throw or give a compilation error, and also flag things like you're doing this, but that's equivalent to this instruction, which is more performant, etc.
I mean, I think vector of t currently, the other one that we worked on for a few years ago, only supports I think 1 of 10 types, right?
Yeah.
So you can compile code that uses any type, but at runtime it will fail with a type initialization error, which seems like something I would probably like us to do because it's the next best thing we can do. Like, do we ever want to support arbitrary structs? Probably not, right? And ideally, if C# ever adds an, where T primitive, then I would like to be able to use it and not have to worry about backwards compat. And realistically, the only backwards compat there would be somebody managed to compile source that they never loaded, which I don't think is a reasonable compat bar.
I'm not sure we'd want to do where T primitive in the future because we're not going to treat things like half as primitive, most likely.
Fair enough. Like where T numeric or something.
Yeah, just as a point of reference for the analyzer, make sure that there's at least a way to turn off that warning, because we do have code paths where we have generic methods where we take a T in, we do all of the checks up front, and then we call in the vector of T under the covers, knowing that the gen will just sort things out. It would be bad if those no longer compiled.
Well, that's the general thing of analyzers, right? You can always turn them off.
You can even turn an error off.
Okay, great. And so then, why did we expand this one but not this one?
So the absolute value one, there's a couple things. Right now, it only supports signed types as input, and it's returning unsigned types as output. So it's questionable whether that should be done or not. But so the set of supported types is not the full set. So in general, we expanded out if the set of the 10 primitive types was not fully supported.
I see. And
or these special cases where the types don't match.
Right, yeah, if you want to change the type, that makes complete sense to me why you would do that.
Why isn't the vector 64 of double overload on there?
Is that a vector of 1 unit?
It's not a vector.
Well, I realize it's not like actually a vector, but it's one of the overloads that the underlying instruction supports.
It doesn't support it because it's not a vector. It's not a SIMD instruction. It's right. A 64-bit double is not a vector. A double is 64-bit, so it's not a vector. So in general, I didn't try to use non-vectors. I didn't create intrinsics for non-vectors. Does that make sense?
Yeah, I think it does.
But when I use the T overloads, so like add below, basically can I make a vector 64 of double and use it if I was so inclined?
Yeah, I don't think it works. And I think in general it'll throw a platform not supported exception.
It looks like it's supported from the Neon Intrinsics page for a 32 and a 64. Like they explicitly show like it's 64 by 1 of T for most of these instructions.
Okay. Well, I'm not sure why you. Okay.
We should probably disagree.
I think it's like the instruction supports it even if it's only one element, and technically it's not a vector.
You're just recording this.
Yeah, I'm typing those.
And to the extent that there are useful places where you would want to use generics, it would be very convenient if it would just work.
Yeah, I guess it's fair.
So I have a question. Absolute value on math returns the same type, correct?
Yeah.
So, like, why do we change the type here? Does it make sense?
Because this doesn't throw, right?
Well, because the underlying instruction says that it takes a signed type and it returns an unsigned type.
But I think you could go either way. I just made a choice. I think the Intel stuff did the same thing. If I would have based it on what Intel did.
Yeah, I was looking, like, did we do absolute value for vector for Intel yet?
For all of the x86 instructions, we basically, if it explicitly said it takes a signed and returns an unsigned or vice versa, then we made sure that the types matched up there. If it didn't matter, then we just supported both.
Because so math says int goes to int, etc., and vector of t says vector of t goes to vector of t. There's no unsigned type
And
equivalent.
there is no like return overload resolution in C#. So, but if you wanted to get an S byte back, then you could just reinterpret cast and it would be a no.
But the value might
Well, but to be consistent, we could just return the same type. What's the
You know it's
negative?
been clamped to a 7-bit value.
What's the negative of returning the same type?
That people may think that it has a particular semantic when it really doesn't.
Like what semantic?
Like the semantic at the instruction level is that it returns a type that is unsigned. So it may have special handling for int.min value as compared to what C# may do if you do int.min value absolute value.
which C# throws right now when you call math.abs.
Yes, good point. So it
Or
doesn't.
the framework throws.
So that's correct, and everything else we've done is wrong.
Okay. Yeah, so if we were starting from scratch, we would basically map that ABS would do the same thing.
Yeah.
I see. Okay.
Because then we wouldn't, yeah, so the min value of every signed type is not representable as that signed type through absolute value. Right?
For reference, this is the absolute, which takes in at 64 1 of t. I would share the screen, but
Yeah, I mean, strictly speaking, you could treat this as the return value as a signed vector. It just wouldn't have negative values in it, but you could put them in it afterwards.
Well, it could have negative values in it. That's
So
the problem.
Right. I mean, the absolute value is going to remove the negative values, but you could put them in again.
Well, but I think the main argument is min value. You cannot do it for min value.
Right. So for as Levi said, for S byte negative 128, absolute value can't edit that one. Well, I mean it'll make it positive 128, but you can't have positive 128 in a signed byte, so that would need to throw if it goes signed byte to signed byte. So So saying it's the unsigned type is correct.
Yeah, especially if we're saying that these correlate directly to instructions that will never throw.
Yeah.
Then
and we've tried, or at least I've tried, to make every account for like we don't do special handling, we don't do transformations that the user might not expect, because for the most part they're writing performance-oriented code, they're taking the risk factor on, and we don't want to introduce unexpected performance issues when they thought that it would do one thing and we decided to do something else.
how would the developer reinterpret cast one of these things? Is there an API for it?
On Intel and x86, there's the sse.staticCast and abx.staticCast, but as per the earlier conversation, it sounds like we're going to move those to the vector 64, vector 128 types.
Well,
and somewhere in the ARM proposal, there's an equivalent.
You can use unsafe.as.
Yeah, that's well.
Well, ideally, we wouldn't force people to use an unsafe API, though, especially since there's no instruction that this corresponds to, right? It's just tell the jitter this is now a different.
Yeah, it's basically ignore the type system and just reinterpret the bits as something else.
Okay, which is safe for primitives.
Well, exactly. Unsafe is safe.
For primitives, yeah.
So do we expect consumers to be generally with specific types, or sometimes using actually generic types? Because the problem with the expansion is as soon as you write generic code, you're screwed. You now have to write a lot of like manual.
Well, you would never call abs with generic T, right?
No, but you can, for example, add, right? So that's what I'm saying. If the consumer is expected to be basically never be generic, you always have a specific type, then the generic ones here just for us to just have fewer methods, right?
I think unless you're writing a general purpose helper library like what vector of T is, then you're probably going to be writing an algorithm that's typed. Like you'll be writing a vectorized implementation of string.indexOf, and your type will explicitly be ushort.
Right.
Or you'll be doing math dot, ceiling, and you'll explicitly be using float or double.
Yeah, I think if we generally expect that the consumers are never generic, like I have no concerns.
I'm sure that there are people who want to be generic and who will write that code, but I don't believe that's going to be the primary use case for the types of algorithms people probably should be writing for performance-oriented code.
Yeah, because the ones that want to use generic, right, they would not, calling ABS would be a pain in the ass.
I think honestly, like without the existence of something like type traits in the framework, like it's going to be very hard to write an application that uses generics, like Cameron was saying.
You'd have to write a helper function that
Yeah.
takes T and then if check each one and software fallback for all the other T's. And
Which could just be this, right?
Yeah.
Which is the only thing.
But I mean, this is exactly what something like type trace would be intended for. We just don't have it.
Yeah, we might have a numeric constraint at some point in the future, right? Who knows?
Yeah, but I mean, that doesn't hold a candle to the power that something like this would have. So.
Right. That's also fair. All right, so then we probably should just scroll over them because unless there's any interesting points, I mean, they all look pretty much what I would expect them to look like without giving them too much thought. Yeah, so multiply is an example where you want to probably mess with the types, right? Or at least explode them to the ones you want to support.
So multiply doesn't support, I think, ulong and long in the short form, maybe. Oh, I don't know. I don't remember. Something wasn't supported here in multiply. I don't remember what.
It looks like vector 64 of double and then there's no long for 128.
Yeah, so long's not supported in 128 is what's actually missing.
yeah, and looking at the intrinsics, I don't see it listed here either.
So you know what could be useful? Adding remarks, basically the comments that you guys just made, add them to remarks of these APIs. Because I can imagine people coding and like, where the heck is this overload?
Mm-hmm.
And then remarks would say, doesn't make sense because multiplying to very large numbers.
As far as I know, we don't have anywhere in our docs system the ability to put comments on a method group.
So what we've done for things like SpanMT is we actually create the method and then have it obsolete as error with a message so that you know exactly what's happening.
Really?
Yeah.
We've done that for what API?
We did it with Git hashcode on SpanMT, for instance.
Oh, okay. Well, because we didn't have it.
I mean,
it exists there.
No, but I mean, I'm actually adding a similar API in the UTF-8 string type, like an API that doesn't have to exist. I'm literally adding it because I predict people will need it, and I want them to type it and then see an error message that says, "Don't do this. You should be doing this other thing instead." It's for discoverability. It's for discoverability.
At the API review.
Yeah,
it's kind of strange. We don't do it.
So, but to be fair, like I don't think that's a bad idea because the problem with these kind of things is also like, as Jeremy said, we don't have really docs for overload groups anymore. We don't even have overload group pages anymore. We just put them all on one giant page. So do you want every single overload to specify every other type it supports? That seems a bit over the top. At this point, it might be easier to just specify, because basically you have to say, I don't support ulong on each of these overloads, right? Which seems
so like adding the method
weird.
as if you call this, the compiler will fail. Does mean that if anybody was reflection finding multiply for their types, they'd find it and now they have to special case. Oh, but if it said long or ulong, then don't do this.
The other alternative
if you call this reflection, if you call these APIs by reflection, you don't do optimized code, I would assert.
Well, or CodeGen, for instance, right?
I would think that these are low enough level and they are specific enough that people are expected to at least have some familiarity with the underlying instruction set that they're writing for, and they would understand why.
And it would be weird that if we add it now and then in 2 years a new instruction set extension comes out, and then we'd go back and be like, don't call this one, call the one that lives over there. And you'd be like, why? It's like, because we break these classes up by instruction set architecture and it lives over there.
Okay, if people run into, I suspect that some people will be using these APIs who can successfully use it, but still don't understand why.
Yeah.
Some of the overloads are missing. If we hit this issue, maybe we can start with remarks at the type level, and then start doing smarter things.
So maybe don't do anything until we really know it's a problem.
Yeah. Until we figure out what problem we need to solve.
Yeah. There is something to be said too for, as you mentioned, like we expect the consumers of these types to kind of understand the instructions.
I don't know. I'm just trying. I learned that .NET has vectorize intrinsic operations, and I just want to multiply to vectors.
I would hope though that because these are buried in a very specific namespace,
Well,
like it would kind of scream to the consumer like, pay attention.
I think the real concern is probably going in the real time where we're going to run into these issues is you're going to have plenty of people who are familiar with x86 code who want to add an ARM equivalent path. They're going to go and assume that ARM operates the same, and it doesn't, and that's probably where people are going to start running into things.
Like the and not stuff you mentioned?
Yeah.
Yeah.
But again, that's a test your code.
Yeah,
If you're
that's-
writing instruction level,
Yeah.
if you're writing assembly, which is what calling this class is, then you need to know what you're doing.
Yes, but it would be good if we had some documentation that helps you get started.
Would
Again,
we,
Meaning, like,
Yeah.
how do I get this information? Where do I learn about the differences? I had Intel code paths, and I just want to port
Right.
to ARM.
I mean, so I think I would expect that our documentation has for each class a link to, like, this is where you go get the instruction set architecture document. And, like, that's pretty much the level of,
Maybe that's a good start.
that's where we stop being able to help you, because
That's-
everything else is,
yeah.
you need to understand what the side effects of this are, and it's all copyright the company that made the instruction set.
Well, I would hope our doc writers can write like 3 paragraphs on what intrinsics are, how they roughly work, and what lack of types mean, right? Because that's probably still at least 2 orders of magnitude more approachable than here's a 500-page instruction set manual. Like, go
Well,
knock yourself out.
For MSVC, we've got a compiler intrinsics page which starts off with a little blurb on what intrinsics are and then links to the various instruction manuals.
Right.
So I noticed that this class was named SIMD, like,
ARM64.sim.
well, yeah. But is that reasonable based off the instruction set architecture name that is being implemented here? Like, because if they do add vector 128 long multiply or whatever, later, people might want. I guess I'm asking, is SIMD named for the instruction set, or are we naming it for the concept? Because if we're naming it for the concept, we're doing people a disservice when it gets extended. later.
So for ARM32, it is formerly called Neon. For ARM64, most people, including MSVC, GCC, and the ARM page on these intrinsics, still call it Neon, but the actual architecture manual no longer calls it Neon. They just call it the SIMD instruction set.
Is that fixed still? What happens if they ship another version of that?
They call the
So
new
this-
version SVE. And Steve, it sounds like you were trying to say something.
So there are some extensions already existing, and maybe I don't know if I have the proposal for it, but if you look at this comment above, this ID AA64 PR0 EL1, that's the identifier in the CPU, and so there's a field in there called Advanced SIMD, and when that's equals 0, which is basically the base SIMD support for ARM64, which basically exists on every ARM64 processor except I think the ones that, well, except for processors which have been given an exception for various architecture-specific uses. So what I think there's a one of SIMD extensions that comes later adds like long polynomial multiplies, and so they just call it. There's a name for that extension, and so this would be another class that's like SIMD long polynomial or something. I don't happen to remember what I proposed or if I proposed it yet, but it would have to be in a separate class. So any extension would go in a separate class, and the name would have to correspond to the architectural proposal.
Right.
So yes,
Should
one
we,
of the big ones is SVE, so it would be in a separate class too.
should we call this class ADV SIMD then to match what we've done with x86, where we just named the class what the basically the CPU ID check is officially documented as?
That's the name of the field. I think the 0 corresponds to SIMD, but someone have to check. So that's the name of the field in that register.
Yeah, because on this one in particular, I'm just concerned that because while this may match the name of the instruction set, it's also the name of the concept, and that might actually just confuse people as they're looking for things from the extensions. And so if there's a word that we can put on here that identifies that this is the SIMD instruction set from whatever, so whether that's ADV SIMD or SIMD 0 or whatever, like just something that helps people understand, like, this is only one particular set of instructions. If what you're looking for is from an extension, go look over the extension class.
And I also don't like that. I know that it's qualified by the namespace name, but we don't tend to have types that are named. We don't have two types that are named the same in the framework. If you strip out the namespace names.
Yeah, we try
Or
to
we
avoid
try
that.
not to.
Say,
We have some.
we definitely have some.
Like user control comes to mind, but I think the question for those kind of things is, are you very likely using them together in one file? Probably.
Yes. For example, you're implementing fallback. So you're implementing some algorithm, and you basically say, if I'm on ARM, then do this, otherwise do this other thing.
Yeah, I guess that's fair.
Yeah, but I mean, I assume that I guess SSE is probably only defined. Is SSE called SSE on both x86 and AMD64?
Yeah.
So
So
we already have that for Intrinsics.
well, the difference is that for x86, AMD 64 is a true extension on top of 32-bit, whereas with ARM 32 and ARM 64 are technically disparate ISAs, and you can't say that ARM 64 is an extension of the previous.
Yeah.
So like with x86, we just have an x86 namespace and then an SSE class. We don't have different for 32 versus 64-bit.
Oh, so they share.
Yeah.
Okay.
Where we can't do that with ARM.
Oh, right, because it is the same instruction coding. It's just the RU 64-bit
Yeah.
op mode. Okay.
It looks like the manual formally calls it Advanced SIMD, and the flag is just ADV SIMD. And so maybe we should call the class that.
Well, I wonder if you should just, given your thing, maybe we should have an ARM64 prefix. I don't know. On every one.
I think the namespace is what does that.
Yeah, like anybody who wants to be trying to do ARM and ARM64, they would just only using up to a certain point, and then I guess they can't. They're using alias the namespace, and then it's ARM64.advsimd.whatever and ARM.advsimd.whatever.
Well, I guess
The language.
There are workarounds.
Yes.
I guess
There are
the
workarounds, but
the actual question here would be for ARM32 versus ARM64. If people want to use using for both, they'd have to do a using alias and rename it to like ARM64 ADVSIMD and ARM32 ADVSIMD.
Well,
and we
there's
tend to not force people to do it, despite the fact that there is a workaround.
Yeah.
I mean, what I usually have done is I just import the other namespace and I just prefix it. Because, I mean, the names are short enough, right? Saying ARM64.SIMD and x86.SIMD, right? They reads reasonably well in that code as well. Like, you don't even have to do aliases for that.
If we were to prefix it, I would vote for A32 and A64, which are the formal short names for the two. But
I mean, regardless of the conflict, I mean, what I care about is that we don't corner ourselves with, as Jeremy said, right? If we name the concept, but then it really is represented as a spec level, then what happens if there's distinct versions, right? I would like our developers to be able to say, oh, it's clear to me that if it's an SSE1, I go to the SSE, and if it's an SSE2, I go to SSE2, and if I'm on SSE2, I, due to inheritance, see SSE1 and SSE2 on the same time, right? I mean, like, it needs to be somewhat sensible that you can reasonably know which time you need to go to in order to get a particular instruction.
yeah, it looks like in the manual it's ADVSIMD, it's 4 bits rather than 1, and a bit pattern of 1111 means it's not implemented. A bit pattern of 0001 implements everything plus half support, and 0 indicates that it implements integer and single support.
So are you saying they have?
They've got it. So they've got 2 forms of advanced SIMD.
Oh God.
So we could call it ADVSIMD and then ADVSIMD half.
Yeah.
Which would be
There's actually,
extra
because
light up
this
on them.
field's got 4 bits in it, they have room for 15.
Yeah, they've got room to extend it.
Document them yet.
So maybe we should call this ADVSIMD
0.
0.
This is the instruction set you get when
Yeah.
at 0 or better. So
I think that seems reasonable to me.
Yeah.
Yeah.
So
I mean, I'd rather have slightly less readable names as long as it's clear what they're referring to.
do we care about, like, do they have a casing rule on ADV SIMD?
They
use our casing.
well
Big
no,
A, little d, little v, big
no,
S?
it's all SIMD is big.
Well, it's SIMD,
Yeah.
but ADV is
Yeah.
actually Pascal case.
And so I would name it that case.
We've not done that with the x86. We've named it according to our casing rules for SSE and etc. So
big A, big S, and a 0 for ADV SIMD 0.
yeah.
What? Say that again.
It,
Why would
Pascal case for SIMD as well.
Oh yeah.
All right.
ADV stands for advanced, right?
Yeah, advanced SIMD.
But ADV is its name. We'll use the name on the class. Also, Christoph likes short names.
No, I don't like abbreviations.
But you also like the names to be short.
I like short words. But no, I think it's fine to call it as the spec calls.
Thank God language is English, not German. I know you've shown words in German.
Well, only because it's a polysynthetic language.
Sorry, only because it's what?
It glues the adjectives into the nouns.
Thank you, okay. So what is that? So basically we said ADV SIMD 0 is the name then?
Yeah.
Hopefully they add they select the numbers in order, incremental.
The only thing I don't like, and maybe I stepped out for 2 seconds, but like a big pattern is you have like a line of ifs, right? If AVX is supported, then do something. If SSE is supported, then do something. If ADV SIMD 0 is supported, it's kind of like SSE and AVX are very x86 specific names, right? ADV SIMD isn't really is it an ARM specific term?
That's the one from
that
the
I could
spec.
just look at this code and it'd be like, oh, obviously I'm on an ARM chip.
And we just pulled that name out of the spec, so yes.
Yeah. Well, I think Eric is asking, like, if I just saw advanced SIMD, would I assume that it's ARM, or would I assume that or could I potentially assume it's something else?
Or what if Intel invents advanced SIMD?
Then it'll be under a different namespace.
To be
But
fair,
what
when
do
you
you call
search
it?
for ADV SIMD, the only thing that shows up on Google is ARM
Stuff
stuff.
under ARM. Yeah.
So I would say that calls this.
Okay.
And
specific.
technically, x86 has already created advanced SIMD. It's called AVX, Advanced Vector Extensions.
Yeah. So Intel would just be, or AMD, they would just be silly to name a new extension set. The same thing that exists in the competitor's set, especially if it has, whether it has the same or different meaning, they're not going to do that because they like trademarks.
All right. Then I guess.
I have to go.
Happy ship rooming.
Ooh, we are done.
Steve, were these just the simple operations in this particular proposal? I noticed there's some like add wide and stuff that aren't here.
So the proposals, these were, I think these are the ones that were actually used by the SIMD vector, the SIMD implementation of the vector class.
Oh.
And so they just were relatively easy to do. So these were like, when I was writing these proposals, it was in the just before shipping 2.1, and I was trying to sort of divvy up work that could be delivered by 2.1.
Okay.
So this is strategically low-hanging fruit.
Okay.
So these are sort of numeric, simple ops that already exist.
To drop a bomb while I walk out the door. We did talk about the generic already, but given that ADV SIMD 0 is these 10 types and ADV SIMD 1 is the half type, should we pre-expand all these generics to be very clear which ones are the 0 and which ones are the 1? Because you would write the line for half, and then we're just going to throw at runtime because you generic expanded when you wanted the one from the other type. So I think we should pre-expand all generics here to the types they support.
So if you know what I mean?
It'll be big and ugly on the class, but it is very, very clear what is and isn't supported.
I don't care about overloads. They collapse nicely. I mean,
Those are my thoughts.
Yeah, we actually went round and round whether to expand them all or not in some of the discussions. I don't know how it's fallen out in the x86 world.
The x86 ones we've still not decided because that's discussion for next week's meeting. But for the most part, we have to have everything exploded due to the way the ISAs are layered. But there's a few where they are generic, and it's not always clear that they definitely should be generic. There's basically no hard set rules today.
Now, was there I thought there was some concern about the size of the manage interface or what it would cost to expand all these.
Yeah, right now they're all recursive, so at least for the platform they're supported, they're recursive. So we
got an order n search for these intrinsics.
Yeah, the search is the search is just to match the method name, not the type name as well. I don't think the type names are done separately after the method name search. But at the IL level, two methods that have the same body can be collapsed to the same IL signature. But if they're all recursive, then they don't collapse. They each have their own method body entry, and so the library gets bigger.
So that's metadata size?
Yeah, the metadata size, because we can't collapse the...
But then, I mean, if it was like thousands of methods, I mean, this is going to add probably, 50 to 100 methods?
No, thousands.
Really?
x86 is like at least 1,000, and ARM's going to be just as big. But for that 1,000 only impacts like the x86 because we've got the multiple builds of core lib. So the x86 core lib for all the ARM instructions throw PNSE directly, so those collapse into one method body. So just the Intel takes space for x86, and it doesn't take any space on ARM, vice versa.
Can we look at how bad it is? I mean, if you talk about 5K, I don't think I care. If you talk like, close to a megabyte, then it becomes...
Well, we could definitely look at the numbers, but if it was too much of a concern, Carol, do you think there would be another way to do the recognition other than recursion if it ever did become a concern?
I have not given it sufficient thought to speculate.
Okay.
Yeah, because I also like extending them because first it makes it very explicit and reliable. Secondly, it's consistent. Like you look at the type and it's consistent. Here it's like, geez, some of them are generic, some are not.
And then you actually get the type safety of I can't pass in my struct.
Yeah.
Well, the other problem that I'm really concerned about is the, adding more types in the future, right? That really breaks it for me.
Yeah.
It's impossible to reason about that when some things are open-ended, but not really.
Many advantages of expanding.
All right, so then took that one. Oh yeah, comparisons.
I see. So it's gonna be the same type, just we broke the PRs into or the issues into.
Yeah. Because it's going to be impossible to review
those
APIs in a single issue.
So maybe I don't understand what this thing does, but like, what does a compare equals 0 do when I pass in vector of float? Like, what does the individual value represent at that point?
So the result, I think it gets set to all ones if it's equal to 0, and if it's not equal to 0, it gets set to 0.
Yeah.
So is it then really, like, should I really interpret the result as a float then, or is it just a bit pattern that I'm...
So what we did with x86 is that for anything that takes or returns a mask, we returned the same type as the input. So if it took a float, it returns a float. And for anything that took a control word instead, we would take and return an integer type rather than like a floating point type. And the reason we did that was because when you're working with masks, you would generally create and construct those based on the result of another operation. Like, for example, compare equal, whereas with control word, the user will be constructing it themselves.
So what is a like? I'm not familiar with the term. What's a control word like?
Well, like
is it just a bit mask effectively?
It's like it's a bit map that controls what the instruction does.
Oh, like bit swiveling, take this and put it there and the other way around.
Yeah,
I see. Versus masking is more like, okay, this is the use it for multiplication, I guess.
Yeah. So like for float, if it's true, it returns basically not a number, but a specific encoding of not a number that's not the same encoding as the single dot not a number.
It is not confusing at all. Okay, I guess that makes sense.
But the main reason for distinguishing that, I mean, in some sense, logically, you'd like to treat the masks as if they were more like an integer, because they're not really used as floats. But it complicates the usage model to have to figure out that, oh, this is a float, so what I need to hold the mask is an int.
But if we expand
Tanner?
Yeah.
But if we expand the APIs to actually not use generics, we could do whatever we want. It will be very simple because you will see in the signature.
You could do whatever you wanted, but like, for example, with floats, you might be doing something like doing an AND, which will return a float, and that can be your mask. And should return a float. So you don't want to have something like compare equal, return not a float, and you have to do something special with it to make it work with the rest of the float in operations.
Yeah, I remember when we did this for a vector of t, that when we actually started writing code, like it became like this horrific thing where you kept casting between values. But the problem is you also have to cast to the right size, so that becomes really like it's not as trivial as you think it is for the most part. And like you usually don't care about the values because you just pass them on, and it's just like things compose much nicer in code, and it becomes much less annoying to read. But yeah. I mean, writing vectorized code in general is not a super straightforward exercise.
But the perfect example really is like you do some operation, you compare to determine which values you want to operate on, and then you pass the results of that compare to and to mask out everything that you don't care about. And if you return an integer type for the mask, then you have to do reinterpret cast to pass it in the and. And that's the most common case, so you don't want to make that overly verbose to do.
Right. Susie, you know what to mean there? Oh yeah, I remember that.
So the parameter name cell, should it be called selector or something like this?
Probably.
I think for x86, most of the time we call it control, but that's also what it's referred to in the spec. If ARM refers to it as select, that's probably a better name for them.
Select or selector?
Select, I would think. Whatever the spec actually refers to it as, I would think would be the better name. Just see if I can find it.
If you look under BSL, I think it's bit select logical or something.
Yeah.
So it basically takes bits either from the left or right.
Yes.
Yeah.
So this is really like the question mark operator with the comparisons from the previous proposal.
Is it clear what the value should be for taking versus not taking? Like for I guess it's
0 left, 1 right. That's what I would guess.
It's 1 left. Well, the comment above it looks like select if the bit's set, it would take the left bit.
Right. But like I mean, it's logically the 1, right? So it's a floating point 1 versus an integer 1, right? Like it's not like a bit pattern that I have to construct by fiddling or something.
Yeah, this is one of the ones where I think for x86 we would have done integer type because the user will probably be constructing the bitwise pattern for left versus right.
Right.
It doesn't correspond to an entire field of left versus an entire field of right. It's an individual bit.
Oh, I see.
So like with x86, there's some masks which are like we take the upper bit of each field,
right,
and then select. Versus
that's what I thought, yeah.
we pack a bit pattern of 0, 1, 2, 3, which corresponds to each element. In which case you'd have to do like a mask and then a bit extract to get, which I think Levi's doing in some of the UTF-8 code.
Okay. So what will be the int? Like all of them, or just the selector? Just the selector, right?
Yeah, I think just the selector.
So you want then all the comparison operations have to change the same, or do you force a cast every time you use this?
In general, this operation doesn't make a lot of sense for floats, correct?
Correct.
Does it even?
I mean, you could, I guess, but it'll be.
That's how ARM's instructions do it, though. Well, if you want to select between floats, you'd still use the same integers instruction. It's just kind of weird.
Because in reality, this isn't treated as a vector anymore. It's just treated as an opaque 64-bit integer for the first method and an opaque 128-bit integer for the second method. Because it's bitwise, not element-wise, right?
Yeah.
So.
There's one of the cases where maybe it's okay to say you have to do reinterpret cast if you really want to do it on floats. I mean, you probably don't want to, but if you really want to, sure.
I mean, right. The normal comparison is going to produce all ones per field or all zeros in a field. So normal case this wouldn't actually be a bitwise select. It just that's how it would be implemented.
So you're saying that this is the ARM equivalent of basically doing a shuffle or an unpack to select the element from left and right that you want in the resulting vector?
Yes.
Okay. So I guess he's saying that this is called bitwise select, but normally you wouldn't do it bitwise. You would do it element-wise.
Yeah, you would choose your bits accordingly so that it effectively is.
In which case you would pass in, the normal case would be you'd be passing in a mask.
Yeah.
Not a manually constructed bit pattern.
But where each element of the mask is all zeros or all ones.
Yes.
Yeah.
Okay.
You could do something crazier if you wanted to, but I guess that's not the normal.
How to do this when the argument is a float, though? Like, I mean, it's not clear to me what the bit pattern for float is.
Well, you could theoretically do it to extract, like just the exponent out. I would guess if you wanted to.
No, I'm just saying, like, how do I get a value typed as float where all bits are set? I don't even know. I mean, for ins,
you would create an int and reinterpret cast.
Well, the compare, if you did compare floats, that's what the result was a vector that had all one set for each of the double fields or the float fields.
Yeah.
Or all zeros.
Makes sense. Right, I took down the notes.
It may be confusing.
I mean, that's the nice thing once we expand, right? We have flexibility, we can remove certain overloads, we can change types, like that's something we can consider then. Let me close this one as well. All right, base 64 SIMD leading zero count.
Yeah, so this one's not advanced SIMD for the first set because they're part of the all ARM64 CPUs have to implement it.
So what would we call the type? ADV base without a number?
Well, these ones aren't even SIMD. These are these operate on scalar types, but they're like the equivalent of pop count or leading zero count.
Mm-hmm.
So you wouldn't want it on SIMD, and there's no
You might call it A64 base.
or something.
So basically, this is so is support will always be true effectively.
If you're on ARM, it's basically the equivalent of a if CPU architecture is ARM 64, then return true.
So why do we want to use A64, not ARM64?
A64 is the formal name for the ARC64.
I heard the words. I'm not sure what they mean.
Yeah, A64 is just the spec name for it.
Okay.
So I think base to me sounds okay, like, but that's something that maybe we should probably be
But I thought we
consistent.
decided we would qualify it. It would be called A64 base.
Yeah, that works for me. First get my cursor back here. So that would be what I'm saying. We would probably use the same thing everywhere else as well, right? So if we have some instructions that are on all Intel CPUs, you would call it I don't know x86 base or whatever.
Something like that. Like if we expose div and idiv, then I would expect them to be.
So prefix H64, now suffix. Base, is it part of the spec or we just invented? Because base in object-oriented APIs kind of imply, maybe misunderstood as it's a base class or something.
x86 and x64, it's formally called the base instruction set. I don't know about ARM, but
I think I made it up for ARM.
Yeah.
I think base probably makes the most sense for the term. Given that these are ISA names, calling it the base ISA makes sense.
You could call it basic if you wanted.
Or would it make sense to call it A64 common?
That's fine too.
Oh no, they call it the A64 base instructions.
If they call it, then I guess it's fine.
Yeah, so I would do like A64 base since that's like the
Works for me. That is look reasonable to me.
Is the existence of a type called base with a capital B going to somehow mess up IntelliSense if you type the C# keyword base?
It's gonna be called A64 base.
But it generally doesn't. It will show up probably. I think base will still show up before, like the keyword will still show up before this because it sorts before that. Sure.
and if it does cause a problem, that's a bug for the Ralston team.
Across all the intrinsics types, are we going to have the same name types underneath the namespaces? Like, I think we're renaming SIMD to advanced SIMD0. Is that going to be in each of the different architecture processors?
No, so with x86, the ISAs have like trademark names like SSE, SSE2, AVX, and that's what they use
It's
today.
not going to be called SIMD then.
Yeah. The abbreviation stands for SIMD. It's just they actually have a trademarked formal abbreviation for it.
Any concerns on this one? Otherwise, close this one as well as looks reasonable.
Oh, looks good.
Extract.
Yeah, and there's that same comment there for byte index must be a JIT constant. Also applies to a lot of the x86 instructions. And what we do today is, if the user passes in a non-constant value, then we emit a fallback, which is basically a jump table for each index. So it's not as efficient, but it still emits the contracted instruction.
Right, and you wouldn't ever expect people to use that. It's just there so that you can debug, you can inflect.
Yeah, if you run a for loop, it might show up.
A number of these reviews had is supported API listed in there. I assume that's only one in this class, right?
Yes.
There's not. We're not intended to have one for each of these groups of API reviews, are we?
Not possible with
No.
C#.
Well, I mean, you could not the same name. But that's why I was going to ask if we need to change the name to group them together.
This is why the idea was that the containing type must be
It's all or
effectively a
nothing.
spec that
Okay.
doesn't change anymore. Right?
Yeah,
Just making
this
sure.
is like if the CPU, the is supported check is basically if the CPU says this ISA is supported, then everything in this class is supported under that ISA. The one difference there is on x86, where you've got the 32-bit, 64-bit extension. There may be a couple specifically long.
So the third platform is supported.
Yeah.
Do we need another is supported switch on there for those extensions, maybe?
If we were to do that, we'd have to create a subclass that contained just the 64-bit ones.
Why?
Because otherwise you'd have like an is supported for 5 or 6 different methods, individual methods, and that would just get insane. It's probably easier just to say, don't do this on.
I just
Yeah,
want to have
so
whether or not
Architecturally,
Go ahead, Steve.
yeah, architecturally, we had sort of decided that we would have one is supported for every sort of architectural extension that was enabled or disabled on a given CPU. And so then if the advanced MD 1 half support was added, it would be a separate class right now. So it would probably be SIMD half or something.
But the extensions
Or
are
advanced MD
exception
half.
to the rule, right? These extensions are only you said they'll only work for longs on.
Well, they're not.
66.
They're not extensions. They're just regular methods.
No, I mean not extension methods in the sense of C# extension methods. I thought they were processor extensions.
Well, so like for example, SSE2 has vector instructions which support, which also support long. But then there's a couple like extract, which might take insert's a better one, which takes a T data, and if for 32-bit, T data can't be long because there is no register for long. But that's completely fine on 64-bit, and they're both under the same ISA.
So
I
how
thought
would people write code
SSE2
for
was a
this?
separate ISA. A separate class, at least.
I don't necessarily think they need to be a separate class, especially if they're overloads. If it's different types. So I'm just wondering whether or not there's something that people can check to determine whether or not this is going to succeed without having to handle the platform not supported exception.
I would hope the analyzer would cover that. And we just tell people, if you're writing these instructions, you really should be using this analyzer.
But do you need to do it at runtime in some cases, right? Because you want to run this code on multiple.
Yeah, but then you can just do, and I don't know if this is a JIT constant right now, but it probably should be if OS architecture, or if process architecture is x86 versus x64.
Okay, so you would do the check that way.
And hopefully we would JIT hold that to be a constant, just like we do with the supported checks.
Right. I mean, the JIT has checks for that, and so they are effectively JIT time constant.
All right.
It knows when it's generating code
Tanner, would you expect this to be a warning if the index parameter is not literal?
For the analyzer, I had planned to emit a warning and say something along the lines of, you're not passing in a constant value, this may have less performance than expected or something.
Why? So if the JIT is generating a switch table like, doesn't that kind of go against what we were saying earlier about these should only correspond to specific instructions?
Well, so what it does is it emits a jump table that basically says switch index case 0, and then it emits the exact instruction with the 0 byte encoding, case 1, exact instruction with the 1 byte index.
Yeah.
So it still calls the exact instruction, but you're only expected to have that happen if you're doing like reflection or something. Like normal code patterns should
You really
never
wouldn't
happen.
want people to be doing this because, you lose efficiency by...
Yeah. So it still emits the documented instruction. It's not like a software fallback or anything. It
Sure.
Yeah. We just thought it was a better experience than throwing in the case where they didn't pass in a const value or did call this via reflection or anything else. It was trivial to support.
Yeah, so the bigger thing that convinced me was that there was a debugging argument. That there were cases where the debugger would actually want to use reflection to invoke something, and there you wouldn't want it to throw.
Okay, that totally makes sense.
You also wouldn't want something like in release mode, the JIT correctly folds this constant down, but in debug mode it doesn't. So this works in release, but then fails in debug mode.
Right.
Yeah.
Good point.
I mean, the names are unfortunate here with insert, but I think other than that.
Have we talked about the namespace yet? Why is it arm.arm64 as opposed to just arm64?
Yeah, that's a good point.
I think that was just the original proposal. I think just ARM64 would make sense, and people would be able to see ARM64 versus ARM32.
Yeah, I would just make them side by side.
Yeah.
I mean, that makes more sense to me.
Is there anything that's common between the two?
I don't
Is there types that should be just in the ARM namespace?
I think we put it there in case of that, but I don't think there is anything yet.
Would it be the end of the world if we made it ARM32 and ARM64 as top level, and then later said, oh, these are common, so we just put them in ARM? Like as a side namespace, they're not nested, but
I think that
do you know what I mean? In case that ever came up,
yeah,
we still have it out there.
Yeah, I think that would make sense to me.
Yeah, I would go with that.
Well, or we could name the namespace system runtime intrinsics ARM, and then the type names would be for ARM64 and.
You have to prefix all the types.
Yeah.
But we are doing this kind of anyway.
Just like how we named the x86 namespace x86, not x86 64.
I mean, right now we only have.
Well, I guess the problem is that we'd have to
types.
rename Advanced SIMD to A64 Advanced SIMD, because it's ADV SIMD on both 64 and 32, but they're basically different instruction sets in some sense.
What are we doing for Intel? Do we have x86 and x64 different?
No, because they are documented
Well,
extensions.
this is what I was asking about earlier. Was I guess maybe I didn't specify, but are they going to have the same type names in two different namespaces? Because that's going to potentially cause problems if you're trying to write code across the namespaces. Like he just told me now that the ARM32 is going to have the same type name as the ARM64 one.
Well, but so if we collapse them into just ARM namespace, we would call them. Probably I would just then drop the advance and call it ARM64 SIMD
Or A64.
or A64 SIMD and A.
Yes, I think that's better too. Having the same type names across namespaces is a recipe for issues.
Unhappiness.
Well, I mean, if anyone hits it, they'll see it, and then they would have to explicitly.
Yeah, that's what it just makes it much more complicated to use the code in the
It's
same
annoying.
source file.
Well, it's annoying, but are there going to be a lot of people who are writing ARM32 performant code since ARM64 seems to be picking up steam?
Yeah, but there's still going to probably be people who want to be able to write code that's going to handle all the processors for different reasons. Yeah.
Maybe not many will do it, but what's the negative? If we think that the negative of dropping this ADV is very large, sure. But if we just do it ARM, A64 or A32, it seems like it would just.
I think you wrote the comment. Yeah, okay, there you go.
So. Let me just refresh this there.
Yeah, I agree. So there's a comment here at the end that there was some discussion about the parameter name and order should be consistent between x86 and ARM64. It looks like I didn't update the order to match x86. It probably correlates to the insert case, which I would guess x86 would have the index at the end.
Would it make sense to just order these same as the operand order of the instruction and not care about matching them up? I think that would also make the runtime handling easier to understand when you're looking at it, because then you don't have to worry about, oh, operand 3 at the C# level is really operand 2 at the instruction level, and so I've got to resort them and have comments in my code indicating why, etc.
When you're translating from the C style intrinsics, do they tend to keep the parameters in the assembly order?
I do not know.
Because if they do, that would be a really good argument for that.
That would be my preference, and that's why I wrote it this way. I think x86 has it in the other order. But it may be that their instruction order goes in a different order.
Yeah, because for x86, the index is always the last, immediate parameter is always the last operand in their encoding.
Oh, okay. Yeah, where ARM you'd actually write v0 bracket slot lane 3, comma something.
Yeah.
Okay, so this makes sense, so it's okay that they're different.
I'd say yes. I mean, in the end, I think it should just match as closely to the instruction as possible for the reasons Tanner mentioned. I think you improve readability for your customers. Alright, so then, actually, no, let me write this up as a note so we don't forget it. Great. Copy paste really works if you actually press the buttons.
This, Tanner, is something that you were talking about.
Yeah.
That should just go into common namespace, right?
Yeah, this is one of the ones where it's core functionality that's basically, but both. It's effectively a helper method for initializing, and.
But this is actually an instruction on ARM64, right?
Well, it's effectively an instruction on Intel as well, but, and I'm not sure if it's the same with ARM64, but at least on x86, you might use one instruction on if you only support SSE, but if you support AVX, you might use a slightly more efficient encoding to do it. And so it's a helper method because depending on the ISA supported, you may do something slightly different to efficiently set all.
So one of the arguments was that the common stuff should be implemented in terms of the base intrinsics at one point. So that if you want to do common, it should be implemented in terms of this and the x86 equivalents.
Right, and so that's like on x86, set all effectively does. If SSE is supported, then do a shuffle. If AVX is supported, do a permute. If you're loading from memory, then do a broadcast, etc.
But that's done in managed code, right? Or it should be done in managed code.
Yeah. It's currently
or
done
C#.
partially in managed code and then a little bit of runtime support.
So this is not an intrinsic. Is that what you're saying?
I think Steve was saying that in ARM's case, this actually is in a single instruction, and you always use this single instruction, whereas with x86, it varies from.
So I would generally say that the way I see these types is they should expose effectively almost all of their instruction set, if that makes sense. And then, as Steve said, what I would do is I would have a generic setter on the types, that is implemented in terms of those. And on ARM, it might just be calling this one method. On x86, it might mean either calling two of them or calling different ones depending on how far the spec level is. And then that's just the way it is.
So what would the common API be? Would it be
Like it would be, I think, a method on vector that says, I don't know, set all to 0 or set all to native or whatever.
So a constructor or a static vector then?
Yeah, something like that.
Yeah.
Probably static factor
Okay.
because for constructors it's a bit
we can
weird.
talk about this later. Because in addition, this method is kind of strange that it basically set in .NET API implies that there's something, the destination and what you set it to. This one is more like create.
Or fill.
Yeah.
This one is not fill, because fill again would take the destination.
Yeah, that's true.
This one is basically create a vector that has these values.
Yes, I mean, like that's it. I mean, the same with the previous method, right? They call it insert, but you don't really insert into the vector, right? You just set a particular element in the vector.
It's effectively insert or set on an immutable type.
Yeah.
Because like if you had an immutable and you exposed an insert method, you expose basically a Fluent API there that creates a new type with the value and returns the new one. Or
So what's the assembly instruction called? The mnemonic.
dupe.
Oh, then why do we remove it and call it set?
Because, well, at least with x86, it's called set because that's what the C intrinsic is called.
Yeah, so there was debate over the months of whether we were trying to keep names consistent with ARM nomenclature or consistent with C# x86 name nomenclature.
But I think we should, like, are we consistent if we choose one and then?
It was basically x86 does it, so maybe we should do ARM the same way. But I would think, for familiarity with people who are already doing that code, we should be calling this duplicate instead, because like for the C++ intrinsic, it's called vdupe _ in _ S8 for signed byte.
Right.
And so people will not go to advanced SIMD and type in set all, they'll type dupe and expect duplicate to come up.
Which seems reasonable to me. I mean, I would agree with Christoph. Like, if you already have to pick a different name, then at least make it one that is consistent with .NET. I mean,
and with what people
or
would
pick
expect
the one
for
that's
that
come with the
platform.
spec. Yeah. Because it seems like set all seems like almost. I mean, set all kind of says it, but set is not the right thing.
And honestly, we would imagine most people would just use the calling functionality anyway for creating one of these things.
Well, especially on x86 when it's more involved, right?
Yeah,
It probably doesn't matter whether you call this one or the other one. I should probably rename.
Yeah, because dupe is effectively broadcast or permute.
Yeah, because to be honest, like using the x86 instructions, like it took me a long time to figure out how to create one of these things from a broadcast scaler.
Yeah.
So.
And that's where the set all is supposed to like abstract that away from you, and why it's the helper method at the x86 level. But then there's also the thing like, today we're exposing set all on SSE, but SSE only supports float, but the SSE set all is also supporting the other 9 types that are not supported until SSE2.
Yes.
And so that moving into a common type.
I don't even remember what method I ended up calling, to be honest. I know I found one.
Right.
Yeah.
Go with this one. All right. Actually, good in time. ARM64 generic intrinsic series 32.
I think the generic intrinsic comment is because both ARM and x86 expose CRC32, so this is where the expose core functionality in addition to the intrinsic some point in the future.
Yeah.
I would be very careful with doing generics at this level. I would honestly say the way I would do it, I would rather have some duplication between the individual hardware stuff and say then there is a completely intrinsified generic BCL API that will always work. I think that's a way better way to factor that than to try to say, oh, they have some overlap, let's try to find some way to share, because for 6 or 7 methods, it doesn't seem to be worth it, and it's probably like
And
a
people
very
will,
small percentage of things you can share.
the people who want the shared functionality will probably go looking for system dot whatever instead.
So what will this type be called?
I believe this is A64 CRC32.
Sounds good.
So what is the name?
A64 CRC32.
64.
What is the CPU ID check for this one?
I don't happen to remember.
I'll see if I can pull it up.
Would 32-bit ARM not support CRC32?
It says that it does, just not the 64-bit forms.
Oh, there we go. Okay.
Am I missing something, or are they just the same 4 method? Oh, there's a C at the end of the second method names.
Yeah, the two algorithms use a slightly different polynomial.
Okay.
So the type name would be called A64 CRC32, even though it also works on 32-bit ARM?
Well, you probably should have
Yes.
then.
Yeah, this is one of those cases where like both expose it, but they're quite different at times in the what exactly it supports. This might be a case of if we're going to put everything under an ARM namespace, if we can look at the spec and determine that they are identical in both CPU check and behavior between ARM32 and ARM64, we should just call it CRC32 or whatever the ISA is. But if there's actual differences between the two, because they're technically distinct ISAs, we should make them separate.
But so if you're on ARM32 and you use
The
ulong, will we kind of simulating software?
No, well, that's something.
It will not be an intrinsic anymore, correct?
Well, that's where today we would say we say it throws a platform not supported.
But why would we not then have a 32-bit CRT32 and a 64 CRT32?
Possibly because we didn't do that for x86, because it only, at least for x86, it applies to like 5 or 6 methods total, and it wasn't worth the additional complexity to support that.
And also we would then need a base, CRC32 base, because if you have a short int, it always works. So we would end up with...
And again, maybe this
Well,
is
you could just make 64-bit.
Yeah, we would have base and 64-bit. We could end up with 2 types.
Yeah. And then you just make one type derive the other, and then you're good to go.
Okay. Yeah, the CPU check for this is ID AA64 ISA R0 ELI1.
I mean, in practice, like, we were considering exposing this through a common type anyway.
Yeah.
So...
Yeah, this is not for kind of usability, it's just for consistency, such that, you know, I can kind of understand, like the document we had at the beginning, those are the rules how we do intrinsics. And then you go into the namespace and you find what we said that the rules are, versus we said the rules are that, and then,
I totally get
I call
that.
this supported. Doesn't work on the
totally
ARM32.
I just don't want to be in a situation where, like, you're adding these exact same 8 methods to another type in the future, right?
Yeah. So if consistency makes implementation easier too. So like a lot of this is table-driven implementation. So if you try to add exceptions where like this class works on both, and I can't answer the ARM64 question, the supported question from ARM64 code, then it gets more complicated.
Yeah.
But that's, you know, you implement it to make it do the right thing anyway. So, but it is a...
Yeah, to me, the biggest problem of these types is not so much usability, because usability is what it is, but I would say that you need to be able to predict where stuff will run and when it will fail, right? And that's why I think it's worthwhile to just mirror the reality here and say, yep, there are 2 types, and it's just 2 different things.
That's right.
Yeah, but so if we make it into 2 types, what are they called? Are they called
I would call
base and 64?
No, I would have an A32 CRC32, and I would have an A64 CRT32, and make that one extend the other.
So if I have an int, now I have to have an if statement.
No, because you would always be able to use a 32-bit version.
Yes.
Oh, so the 30, okay.
Because the 64-bit version would simply subclass the 32-bit
makes sense.
one.
Well,
you
subclass.
that?
It's a static class, so it would.
It wouldn't be static.
No, it would be. So you can still derive from it. So you just don't make it a static type. You just make it a private. Make it basically just sealed, and then the compiler basically does the
I
rest
see.
for you.
So we make it. It won't be a static class.
It's what we did
Correct.
with the x86 instructions, where we have like AVX2's class, subclassing AVX.
The difference there, though, is that like it's been said multiple times, like
Yeah.
x64 is a direct extension of the 32-bit. You cannot implement the 64-bit without the 32-bit. Whereas with ARM, ARC64 is not strictly speaking an extension of ARC32.
Okay.
So you can't necessarily say that CRC32 ARC64 extends from CRC.
Well, what you said is true for other intrinsics, but for CRC32, it happens to be true that they are.
It might be true. I'm trying to determine that now. But if it even then, it still might not necessarily be a safe assumption.
It seems like it's not a common enough case that we want a special case. This one inheriting from an ARM32 class. It seems suspicious.
So basically, we would have two types, and you have to know that according to what you just said, you cannot even know that you can call these instructions on ARM64.
Yeah, which is why originally they were in two different namespaces here.
But then,
Right. This was justifying putting it in an ARM64. This sentence at the bottom was just justifying putting it in the ARM64 namespace.
so maybe
instead
we
of
just
it
have two.
in a common.
We have two types, and then if you have a short int and you want to have a support for both 64 and 32, you write an if statement. It's not, as you said, it's not that common. Like ARM32 is going away, so like soon it will be a non-issue. Meanwhile, if you want to write adaptive code, you just have an if statement.
Right, works for me.
ARM32 is famous last words, just like how x86 is going away.
So is it then fair to say that the ARM64 will basically has a copy of the 32-bit methods? They're defined in both places, and you check either one of them. Okay. Works for me. All right. Load, store, and cast.
Are these aligned or unaligned?
In the assembly code, there's no reason to require them to be aligned.
Okay.
Yeah, and for x86 we did load vector is unaligned, and then load vector aligned is aligned.
But it sounds like ARM doesn't distinguish between the two now. It used to. Does it not anymore? Maybe never for vectors.
There are some instructions that require aligned and some that don't. If you turn alignment on in the OS, but I think all the OSs have it off right now, if I remember correctly.
So you're saying that the underlying instruction's behavior depends on potentially a flag setting that the OS could set?
Yeah, I think so. I'm not sure though. I think the basic loads, it's not the. I don't know. I'd have to think.
Well, I guess
I'd have to go look at it.
the meta question is like, with these particular APIs, can I write an application that works correctly regardless of what the OS or processor setting might be?
If you just make them aligned, then yes.
Well, but the data might not be aligned. Like the data might be coming in from the network. Like it might not be aligned.
Yeah.
I might just be saying, read these bytes from this arbitrary pointer and make it a vector register.
Let me see.
Right. I think the assumption was that. Yeah.
I guess I could always use unsafe read on a line. That should work, right? Even on ARM. Okay.
Yeah,
Never mind.
I'm trying to look at the manual right now.
So a lot of these correspond to basically a load of a vector, which most of them support bytes, so if it just corresponds to a byte-oriented load, then the load's not going to have an alignment fault. So the element has to be aligned.
In Intel, at least, it's not that the element has to be aligned; it's that the vector itself has to be aligned. Because
Yeah, I think this is actually just the element has to be aligned for these, if I remember correctly. But Tanner's looking.
Yeah. Trying to find it at least. It's got this really cryptic, if n equals 31, then check alignment, otherwise don't. Oh, n comes from the rn parameter. It looks like it might be a setting you can encode as part of the instruction encoding, if I'm reading this right.
Does that imply that we would want a line overload? It wouldn't be an overload, it would be a new method at that point.
If you can actually encode both versions of the instruction, I would say yes. But I'm not familiar enough with reading the ARM manual to say for sure.
Sure.
Yeah, it would be good to just, figure it out before we ship, because then we would add the suffix.
It also gives consistency with x86, which I know isn't terribly important, but
Well, I mean, thinking about alignment, I mean, we should probably be somewhat specific about how we would encode this in instructions in terms of names. I think that's a good point.
Well, we would at least want to say, like, this is guaranteed to work even in the face of unaligned data.
That's what I meant. Like, either you say, either suffixes you don't, or whatever the rules are. But all right, so I think just do some homework. I would just leave it. The other ones are fine. Like the static cast is also one that we probably want to have on the generic vectors, right?
Well, what exactly would static cast do here? Like, it says move, but it's not really a move, right? Isn't it just saying, hey, JIT, this register is now a different type?
Oh, yeah, so static, well, unless Steve had a different idea for it, this was supposed to be basically reinterpret cast, but with the same name as x86 does, which is static cast.
Right, but reinterpret cast doesn't correspond to the instruction.
It's supposed to be a no-op in all cases.
Right. Yeah, I think that this corresponds to a move in ARM64 JIT, but if the move is to the same register, the move just gets eliminated. Because a static cast here could create it, because it's creating a new object, that could go into a new register. Just because you cast it, so it doesn't mean the old object's going to disappear.
No, of course, but it seems like move doesn't really belong as an intrinsic.
Yeah. This is really a static cast.
Yeah. So it's just the comments just.
Yeah.
I think.
Yeah, the comment maybe want to be cleaned up.
I think what Steve was just saying was how the static cast was originally implemented for x86 as well, which was we basically say by the time we got to CodeGen, if target register and source register were the same, then we just dropped it. Otherwise, we did a move. But then Carol suggested that in the importer, we just eliminate the static cast there.
Yeah.
And then basically you never see static cast past the importer.
So I have a related question along those lines. Consider APIs like and not, like the single and not API. Is the JIT free to say, you have vectors A and B, you're inverting B and then anding it with A, you've called two different instructions, but I'm still going to collapse them to a single and not. Is that a valid optimization?
We don't do that today, and there's still discussion on whether or not we should do that, because the user may be taking advantage of pipelining or something else. But that's still like an up in the air discussion.
But it sounds like you might want to reserve the right to. Okay.
Yeah, like
I think I have a question.
Yeah, like all the native compilers do this in other optimizations. Like if they see a shuffle by like 0x68, they convert it to an unpacked low instead of doing a shuffle because it does the same logical operation, but it's more efficient in coding.
Okay.
We don't do that today, and there's still an open issue of like, should we allow this or should we just say we will never do this and we'll rely on an analyzer to tell you you should be doing this instead.
Got it.
That way the users get at least deterministic behavior and they can pipeline as they see fit and trust that it will work correctly.
So these are using void star addresses. I was always surprised that you guys didn't choose to use a span. Is there some reason span doesn't work here?
So the reason this is also an open discussion. There's some users who want us to add either ref of t or span overloads, and I, after having thought this over a lot and discussed with various people, I am against it. And the reason being that, at least with x86, oftentimes you are doing this with performance-oriented code, and you are wanting to do things like work with a large number of elements in an array. And so the typical operation should be I pin this, I do something to make sure that the rest of the data is aligned, and then I operate on all of the data as if it was aligned till the end. Because otherwise the GC is free to move your types around if it's in a span or a ref. And that will kill cache locality, that will kill alignment checks, and everything else. So in the end, it just ends up being better for users to pin their types and operate it on it under the assumption that it is pinned.
Well, Dr. Sappa, if you took ref of t, you would want to prefix every single method with save, which gets silly.
Yeah. And if someone does have a span of t, they can just fix the span of t and operate on it then. Because the normal case shouldn't be I'm doing one operation on a span. It should be I'm operating on the entire span, or a large subset of it.
We can always also add span overloads later if people insist.
Yeah.
It's fine.
Yeah, I agree with the ref of t stuff though.
Yeah, ref of t I agree. Span I'm on the fence.
Sure.
I think it would be.
Well,
some people would like it.
There are APIs right now on Memory Marshal, I believe, that can go from span of byte into a vector 60.
But then suddenly you deal with unsafe code, which is like not important. I mean, it's all safe, right?
I mean, I understand the reason why you want to have a pointer one, but is there any reason why you cannot also have a span one? I mean, like, you can't just make them overloads, right?
Well, yeah, you could just have them, but that may promote people to do the wrong thing. Like basically, the difference between using a span directly and pinning a span and using it for a large array is multiple orders of magnitude of perf difference.
No, but you would inside, if you take a span, you would inside pin it.
Well, then why not just use the pointer?
Because the user doesn't have to have unsafe code.
You have to have unsafe code to pin a span.
Why do you have to pin this at all?
Code, but not the user code. User code that has a span and calls this method would be completely safe.
Yeah, but that could also be provided in a helper library, not as part of the core API.
Well, everything, so many things could be provided.
I mean, nothing's stopping us from adding it, right? In the future, if we decide it's a good idea.
So, Steve, to answer your question, the reason that you basically have to pin it is because otherwise the GC can move the underlying span, and then you're stuck with, oh, I read from address X, and now I'm reading from new address X rather than address X plus 1.
Right, but if you're passing in a span, the garbage collector, when it moved, it would update the span, and so the span would be consumed, and it would be just like any other time the span was moved.
Right, but the underlying reference was relocated, and now you've messed up cache locality and non-temporal stores and everything else that you may have wanted to optimize your code to do.
Also, you have to answer the alignment question too, which was an open issue.
Yeah, you no longer have the ability to say this was definitely aligned because it was before.
Because it needs to be aligned on vector
Well, for,
alignment?
At least on x86 it does.
yeah, on x86 there's an explicit like load aligned instruction, which basically
But on what boundaries?
But objects in the heap are aligned to like 8-byte boundaries.
Only to the natural word size.
they are not 16-byte or 32-byte aligned, which is many times important or required for vector types. So you prevent a read crossing a cache line boundary, which will drop your perf considerably.
It just seems like you've sort of inverted it. If you want to pin it so you don't want it to move, you pin it so you don't want to move. The intrinsics don't require the pinning, though.
No, but it encourages the correct behavior for I'm writing code that's dealing with high performance. If you don't pin it, then you're going to get unexpected perf hits. Most of the time, people will be wanting to pin it, and that's how they will be operating on it.
Yeah,
Okay,
but
that's
pinning
the
also
flow.
impacts negatively performance of the GC. So, I'm
So
not
I
sure
took an
what
action
the
item on the meta
net
thing.
is.
Should methods deal with pointers also except span of t, or instead of that? I think it's a broader design issue that you guys should figure out. But I think that's let's take the node and then.
And almost a moot point because as we said, we would probably inside the implementation of the method, the span would be pinned and just call this one. It's just a convenience for the caller, so they don't have to have unsafe blocks.
Right. All right, two more. Can we wrap them up, or should we? I mean, we're 50 minutes over. Like I don't know how much time these will need, but all these are crypto. Should we just wave them through? Is that what we do this?
Jeremy would want you to approve these. I would want you to approve.
Well, I think the question was the same one that came up for x86. It's like AES, sure. SHA-1, technically SHA-1 is completely deprecated. There's still people who may want to use it for non-cryptographic purposes. Should we still expose it?
SHA-1 still has its uses even for cryptography. HMAC SHA-1 is not busted, for instance. Someone is going to comment on the video after the fact and say, but it is! So, whatever.
Yeah.
I honestly, if I want to read a Git repo in a fast way, is there any reason why I shouldn't use, those ones, for example?
Other than the fact, at the enterprise level, various corporations will say, I don't care what you're using SHA-1 for, just don't use it.
Yeah.
So it's just that question. Even we have rules of, you're not allowed to use SHA-1 for anything, no exceptions, except for the already exposed APIs.
Policy at that level, to me, honestly, if you want to enforce that, fine, then you write a rule for that, or you code audit or whatever, but it seems like not giving people functionality just because somebody might not like it is, I think, generally not a...
I would personally vote to expose it. I was just making sure to raise this is the same thing that came up for Intel where we said we're not exposing it because of this. So, I think maybe Jeremy was the one who raised it last time.
Yeah. So I have a comment about the _c parameter name.
Yeah, we should not do that.
Yeah, there's an open issue to rename these parameters. Unfortunately, I don't understand the algorithms well enough, and I didn't really write this. I probably cut and pasted this proposal, but I didn't actually write it.
These parameters correspond to words 0 through 3, words 4 through 7, words 8 through 11, blah, blah. If you look at the actual algorithm itself, those parameter names actually make sense. But wow.
Yeah, I think you can come up with a name that doesn't have an underscore. And there's other ones here hash ABCD and WK. I mean, there's probably some.
But somebody who understands the semantics would be good to work with you guys on the names because some transformations may not be trivial, like W0_3. Unless you know that it's from 0 to 3, you probably wouldn't know how to name it.
I shouldn't have said a word. It's not a word. It's separate. But yeah.
All right. Anything else on this?
In the case where the algorithm explicitly names it whatever name, we typically use that name, right? Even though if it breaks our naming conventions.
No.
What
really?
Yeah.
Yeah. What I was saying is that if you actually look at the SHA algorithm, these terms actually appear in the math.
Yeah.
Well, I would say if it's a random abstract thing that is a parameter.
We have public
math,
APIs in cryptography that have properties named E and W.
Well, I would say,
But
generally
that's
speaking,
not-
cryptography is not a shining beacon of usability. But I think,
Well, that's exactly what this is, though.
yeah, what I would know, but I would say like it depends on why they're named this way, right? Sometimes they're just lazy; they're just named buffer BAVR, and there's no reason why they should be named like that, right? And there's other cases where you named a parameter coming from some math that just happens to be called E in any sort of math paper, and that's the only sensible name for that. In which case, it's fine, right? So, but I think there's there's no reason why, RSA should be spelled out, for example, right? But there's also no reason why RSA should be all uppercase, right? I mean, so there's like conventions and there's rules, and then there's what's the name of the thing, right? And sometimes the name of the thing is the name of the thing, and that's fine. But I think that's not necessarily the problem here, right?
Also, I would say even in the crypto namespaces, I don't think we have many underscores.
We don't.
Oh, we have plenty of
We have
violations.
some.
No underscores.
Yeah, exactly. We removed them. That was the cleanup.
But I mean, he is right though. We have D, E, and Q.
Yeah.
But that's also because the actual algorithms refer to those variables as
And
E, D,
yeah,
and
so I would try to keep the names such that you can, if you understand the spec,
Yeah.
you can look at this parameter name in Manage API and you can make a connection.
Sure.
But try to initialize the names, no underscores and proper casing.
All right, last one. And then we go to lunch.
Okay, to answer the aligned question from earlier, there are explicit instructions, LDXR, which requires alignment, versus LDR, which does not require alignment. There's basically two different instructions there, just like on x86.
So maybe we would expose both.
Yeah, we'd probably expose a load. It's called load exclusive and store exclusive instructions, but
Well, those are exclusives. That's not just a normal load.
Exclusive
That's
is
for
in
building atomics. So the exclusive comments, you do a load exclusive, store exclusive. The store exclusive fails if someone else wrote to that before you, between your load and your store.
yeah. Okay. But those ones require alignment, whereas the regular LDR does not. But there is a OS level flag for require stack alignment, which is different.
So I just wrote up the note.
In ARM64, the stack always requires alignment, but that's a different thing.
So I wrote it up. I'll share it, and
Okay.
then you can decide what to do with it. All right. So more Cindy stuff.
I don't think there's anything new here.
Yeah, I was about to say that seems pretty much in line with what we said earlier. No pun intended.
So the pairwise and across, the pairwise adds pairs of instructions within the vector, but it's naming convention from ARM. And across, I think I copied that from x64 or x86. Sorry.
For things like extract, are you going to do the same thing for debugging, where if the input's not a constant, you build up a switch or something?
For which ones?
Extract OT, where it says index must be a JIT-time constant.
Yes.
So that's the same thing's going on.
Yeah, so it's a switch table underneath, and I think in this case, because it's not a full range immediate, it's a partial range. If it's outside that partial range, then it will throw an argument out of range exception.
Sure.
Yeah.
Yeah, I like across and pairwise more than vertical and horizontal, which I heard before, which is not super helpful.
Is there no long and U-long for these? For things like max pairwise?
I think, there are strange places in the ARM instruction set, ARM64 instruction set, where long is not supported yet.
Okay.
They ran out of time.
Yeah. Who needs more than 32-bit?
I mean, as long as it's not an oversight here, if there's no instruction for it, then what are you going to do?
Yeah, they're usually called out fully expanded when long wasn't supported. That's one of the most common cases.
Okay.
And,
that's what I read.
and just like with x86, I'm sure there's possibly typos in some of these, and we'll come across them as we implement them, and then log an issue, get it temporarily fixed, and then come back post-implementation like we're going to do next week for x86 and be like, does this all look correct?
Yeah, those are the kind of things.
So
I'm concerned about.
regarding implementation, I think most of these things are actually implemented. The load and store are not yet. Everything else, I think, is implemented that we've reviewed today. Obviously, the changes haven't been implemented. But.
And that looks reasonable.
Right.
Sweet.
Done?
Then I think we're done for today.
What do we want to say about the rest of the advanced SIMD instructions that we haven't reviewed that weren't part of a proposal but still exist? Like there's a number of them that didn't show up in any of these that presumably.
Yeah, my guess is 90% of them aren't proposed yet, or 80%. Something like that.
So
Yeah, there's like 4,000 of them. If I take what I copied off the Neon page, it looks like there's roughly 4,000 different total methods, including overloads.
What do you mean by they exist? They exist in the processor, not in our API set.
Well, yeah. So, like for example, I didn't see add wide up here, which is one of the instructions that is exposed as part of the advanced MD instruction set, but wasn't part of any of these 6 or 7 proposals that we went through so far.
Where the result is wider than the input.
Yeah. It's basically like byte plus byte equals U short without the intermediate.
And the reason
paths.
they are not in the proposal is because they are not yet implemented, that you guys don't think that they should be implemented?
No, because there's like 4,000 APIs in total, and it would take way too long to put them all in individual proposals.
So, I mean, my argument, generally speaking, is, I mean, I don't care about spec completeness, right? To me, it's more about, like, yeah, if we only ever needed these 13 methods from the 4,000 spec and nobody ever complained, then that was a good MVP for us to ship, right?
Yeah.
It would be nice if we had a recipe where somebody could step in and add an intrinsic, and we kind of know, okay, you have to add this method here, put this attribute on it, change it over here, add the test over there, and then rinse and repeat. And then we can probably crowdsource that to a certain extent to interested parties as well. I mean, my hope is that most of them are also motivated by what people ask for, and not just us randomly picking from the spec.
Yeah.
In which case, yeah, I don't think the problem with not having.
But you see, so this is, I still didn't understand. Is it an issue? You said because there are 4,000 of them, and putting them in a separate proposal would be
for example,
a lot of work. Is it to put them in the proposal and review, or you actually have a problem implementing them?
No, it's putting the proposal and reviewing it. Like, so for x86, when we did it originally, behind the closed doors and whatever, we basically had the Intel come in and be like, here's the proposal, here's the abstract concept, and here's a few select pieces of it, but we're proposing like this entire ISA be implemented.
Right.
And now we've gone and implemented it. Are we also saying that for ARC64, we have looked at several of the APIs, we've determined that this ISA is useful, we'll implement it, and we're going to implement everything because they're exposed for specific reasons. We just don't have time to review them all in one sitting.
Well, I mean,
if we have time to implement it, how do we don't have time to review it?
Yeah, that would be my
Well,
question too.
we do, but it would probably take just as much time to like type up the proposal and separate out all 4,000 APIs as it would require to implement them.
No, so here's what I would do. So what I think is that, so I think we have enough handle on what the patterns are.
Yeah.
But that is usually what I try to get out of the review. If now somebody dumps effectively the PR and says, here's like a 3,000 line delta in an API, and we can quickly go over that, is this consistent, yes or no?
Yeah.
I mean, when we reviewed Roslyn, they had 25,000 APIs.
Right.
We did not look over all of them. We looked at like 3 of the syntax APIs and said, okay, that's the pattern you have. The rest is just the rest.
Yeah.
Right?
In other words, implement it, and then we have a tool to generate API listening, and then we can even review it kind of offline, like send an email and said, as far as I'm concerned, they all follow the same pattern that we discussed at the review. If somebody finds an issue, please let me know.
Yeah, and that's basically what I was asking, because what I would like to do is, after I ate lunch today, go sit down, open an up for grabs issue on CoreFX and CoreCLR saying ARC64 Advanced SIMD and ARC32 Advanced SIMD has been approved.
Right.
Yeah.
These ones have been formally reviewed. You can go ahead and implement them if you feel like you're up to the task. And the rest of them have been basically preliminarily reviewed and will be approved, and they'll be reviewed as the PRs come in.
Yeah,
Yeah.
that works.
So quick question: do these two overloads actually exist, or was that a copy paste error? Reverse element bytes on floating point.
Let me check.
How you doing? Lunch and anybody want to go?
Lunch? Yeah.
Be back lunch? Sure.
All right. 1 minute.
I think it's there. I think they don't correspond to necessarily assembly instructions, but I think it was for like when you read a file and it was a big endian file and you're on a little endian system, you need to reverse the elements of the bytes. So if you read from
floats.
memory,
Floats are encoded according to the big endian architecture as well, because it's bytewise or wordwise.
Okay. Yeah. All right. So then no issue then. All right. Then I will call it a day. And thanks guys online. And then I see you later.
Thank you.
Thanks.